All right, so a problem, the problem would be something like this. It would say to use the quadratic formula QF to solve this equation.
Okay.
Okay, and there are three values that you need to be able to solve the quadratic equation: A, B, and C. Okay, so
Yeah.
A is the number in front of x squared, B is the number in front of x, and C is the other number. Okay, so what number is in front of x squared? What is not written but is in front of x squared?
Okay, so wait, what?
What is the number in front of x squared?
X x squared, a number in front of x, it's x. And
Nope.
it's 2.
Nope. The exponent is 2. X is a letter. What is the number that is not written but is in front of x squared?
One.
1. Okay. What is the number? B is the number that is in front of x.
Yeah.
What is the number in front of x?
The number in front of x is 5.
Yes, it is. Okay. And then C is the other number. What is the other number here?
The other number?
Yep. What is the other number here?
4.
4. Great. Okay, so the next thing that, and this is kind of the steps here. This is step 1 of the quadratic formula. I'm going to kind of modify to keep it simpler. Step 2 is to determine this value called b squared minus 4 times a times c.
Okay.
Okay, so you have to take your b value, 5, square it, your a value, which is 1, and your c value, which is 4. So we're just taking these numbers, plugging them in, and then you have to simplify this.
Okay. All right.
So if you've got pencil and paper, go ahead and work this out, or if you need a calculator, that's fine with me, but this is very much a part of the quadratic formula here. You've got to be able to perform this operation.
Okay. So 4 times 1 is 4. And 5 squared is 10.
5 squared is 25. It's 5 times
Oh,
5.
sorry about that.
No problem.
It's 25. Yeah. 25. And then 4 times 1 is 4.
You got another 4 here that you're multiplying by.
Yeah. It's -4 times 4. 16.
Yep. Okay, so that's 25 minus 16. What does that equal?
9.
Perfect. Okay. So step 3 is to write out the quadratic formula, and I'm going to write it out for you each time.
Yeah. Okay.
So that's the quadratic formula. Okay, and just I'm going to remind you that A is 1, B is 5, and C is 4. Okay. Now the part I'm about to highlight, this part right here, b squared minus 4ac, we already did that. Do you see that you already did that part?
Yeah.
Great. So the reason I ask is because we don't have to do it again. This part underneath is 9. It's 9 for this problem. Okay. Minus B is minus 5 because B is 5. A is 1. So see how we're just substituting numbers into the formula? So you're putting B of 5 in, A of 1 in, and get to this line here. Is that okay?
Yeah.
Okay. What is the square root of 9?
3.
3. So this becomes minus 5 plus or minus 3 over 2.
Yeah.
Okay. And there's what's called implied parentheses in the numerator. And that means you have to do the numerator first. Okay, so solution 1 or answer 1, we'll go with answer 1. Answer 1 is minus 5 plus 3 divided by 2. And answer 2 is the other way, minus 5 minus 3 divided by 2.
Okay.
So see how you break apart this plus minus into 2 possibilities?
Yeah, it's just like going to different substances right there.
Yes. So minus 5 plus 3 is minus 2 over 2, which is minus 1. And the second one here is minus 8 over 2, which is minus 4.
Yeah. Okay.
Okay, so the challenge is to determine each of these values and be able to evaluate it. Okay, so let's look at another question.
Yeah. Okay.
Okay, so the problem would say to use the quadratic formula to solve. Okay.
Yeah.
All right, so we got to do this again. A, B, and C. So A is the number in front of x squared. What is the number in front of x squared?
The number in front of x squared.
Yes.
Z 1.
It is 1. B is the number in front of x. What is the number in front of x?
The number B is a number in front of x. What number is in front of x? Just 1 again.
Here's x. This is
Okay.
x.
It's
What's-
7.
It's 7. C is the other
And then
number.
C is 10.
Perfect. Okay, so I want you to calculate b squared minus 4ac. I want you to calculate. That's b. A is 1, c is 10. Could you calculate that for me, please? Do you have a final answer for me, Sourish?
Yeah. So for that right there, -4 times 1 is -4. -4 times 10 is -40, and then 7 squared is 49.
Okay, that's very good. But what is the final number? I want the last number here.
Nine.
9. Very good. Okay, so I'll write the quadratic formula. It is opposite of b plus or minus the square root of b squared minus 4ac all over 2a. As a reminder, a is 1, b is 7, and c is 10. The part under the square root you already calculated. Do you see that? You already calculated that.
Yes.
So 9 is the number that goes into the square root. Now it just happened to be 9 again in this problem, but it is not always 9. Okay, so it's minus 7 plus or minus the square root of 9 over 2 times 1. What is the square root of 9?
Okay, so now for that
Do-
right there, you just have to add -7 plus 9. That equals
Did you hear the question that I was asking, or do you want me to repeat it?
one last time.
What is the square root of 9?
3.
Okay, so now, as I mentioned before, this is really two things. It's -7 plus 3 divided by
Yeah.
2, and it's -7 minus 3 divided by 2.
-7 plus 3 is -7 plus 3 is -10, and then 2 is
This one is -10 on the right.
-7 plus 3 is 10. That's 10, right?
It's -4.
-4. Okay. Yeah, -4.
Okay, -4 divided by 2. What is that?
-4 divided by 2. -4 divided by 2. -4 divided by 2 is -4 divided by 2. -2.
Okay, and then what is -10 divided by 2?
-10 divided by 2. -10 divided by 2 is 5. -5.
-5, good. All right, we're gonna do one more example.
And then we'll be done.
No, we're gonna do one more example to see if I can get you to do a little more of this on your own, but we can switch topics after this. It's not all that interesting, but I should ask you, do you find this topic interesting?
Yeah, I just found it very interesting. Yeah.
Really? I'm surprised. I don't think this is very interesting at all.
Well, quadratic formulas, I just don't know what to do with it. Just
Right.
math tough.
Right. So let's do one more of these, and then we'll talk about some applications that may be interesting. So give me A, give me B, and give me C for this, please.
Yeah, okay. A is 1,
Okay,
B
good.
is 10, and C is 16.
Okay, so B is actually -10 because it takes on the
Oh
sign,
yeah, I know.
the sign of that. And I didn't say that, but now you understand. So now we're going to do B squared minus 4 AC. Okay. And this time though, when you substitute in for B, you want to put it in parentheses
Okay.
because you're squaring -10. And when you square a negative, it becomes positive. Okay, so I want you to give me the final number here.
Okay. Okay. All right. And for that right there is -20 and -64.
Okay, but -10 squared means -10 times 10.
Yeah, and it's uh -20.
-10 squared means -10 times -10.
Yeah, I know.
You're multiplying.
Yeah.
What is 10 times 10?
Oh, wait a minute, 100.
Okay, and what is a negative
I'm
times a
sorry.
negative?
I'm
It's
so
100,
sorry.
right? Minus, what is 4 times 1 times 16?
64.
Okay, and what is the net result?
And then results
What is 100 minus 64?
64.
No, I mean 100 minus 64. It's rare that it's the number that you just started with, the second number. What is 100 minus 64?
36.
36, very good. Okay, now we write the quadratic formula. X equals opposite of B plus or minus the square root of B squared minus 4AC all over 2A. What is the part underneath the square root? What is the number right here? What number goes here?
Number.
Yep, what number goes here?
What number goes there? The number that goes there is the number that goes there. The number that goes there is 36.
Yes, 36 goes in that position. Okay, so we're going to substitute the numbers in. Negative B, negative of -10, plus or minus the square root of 36, all over 2 times 1. Okay.
Okay, yeah.
What is the square root of 36?
The square root of 36.
Yes,
Square root of 36. Square root of 36 is the square root of 36 is 6.
it is 6. So this becomes 10 because the negative of a negative makes 10, plus or minus 6 over 2.
Yeah.
So will you go ahead and tell me what the two possible answers are?
The two possible answers are?
Yeah, we did this in the previous problem. It's almost exactly the same. If you want, I can scroll up to show you.
No. Okay, so for that right there, 10 plus or minus 6 is 16, and then divided by 2 is 8.
Okay, so that's one answer, 10 plus 6 divided by 2. That's definitely 8. What is the other one?
4 and 2.
So it's 10 minus 6 over 2, which is, well, I think you did say it, but what's the final number that goes here?
2.
Yes, it becomes 2. All right, so let's talk about quadratics, applications of quadratics. The most common one is what's called projectile motion.
Okay.
Did you ever play soccer at any point?
Soccer?
Yes. Have you played soccer, baseball, golf, potentially? Have you played any of those?
Have I played soccer, but then I'm done with soccer.
Of course, yeah, but this is just your memory. So you played soccer. Now, at some point, you probably kicked a soccer ball, okay, and it went up in the air and came back down.
Yeah, okay.
You can remember that, and maybe you dropped it and kicked it up and it went down, something like that. Is that okay? Like you remember doing this, or you watched a friend from the sideline do this, or a teammate. Is that all right?
Yeah.
Okay, so projectile motion, which occurs in a lot of sports, is a quadratic equation, or it can be approximated by a quadratic equation. All right.
Yeah.
So, for example, a scenario is like you just said, you drop kick a ball. So you're doing it maybe at knee height. You kick it up, and you want to know, maybe you want to know how high it went.
Yeah.
Okay. Maybe you want to know how far it went.
Yeah.
Maybe you want to know the time in the air. Okay.
Yeah.
So another possible scenario, and these are a little kind of wonky, but they're they're scenarios here. Let's say you've got a roof, tall roof, and you've got a swimming pool.
Yeah.
When you jump, let's say you were to jump, or a person were to jump, maybe not you, but a person. If a person were to jump, their motion is considered parabolic.
Okay.
So this is called projectile motion. Okay, and what we could do is we could figure out, well, will the person land in the water? That might be a question that could be asked. Okay. So
Okay.
projectile motion typically deals with things that are either in one dimension or two dimensions, and they typically are things that are moving. Okay. Now you're playing. You said you play Minecraft. When you jump off of something in Minecraft, do you fall straight down? Do you jump out? What are some possibilities? Like if you get to a tall structure, what ends up happening?
What tall structure?
seen in Minecraft that are tall structures?
Yeah, well, tall structures like mountains.
Something you build. I mean, just like what do you?
Well, I make it like a little bit like for I make it a little for how many cobblestones I can build I build a cobblestone house with a copper roof. I build it like into 40. I think I build it into like I think I build it into like 46 cobblestone blocks and also 20 copper on my house, I think, on my roof.
Okay, and so like if you were up here, like you could like here's one path. You could just go straight down. Another is maybe if you got a running start, you might look something like this. And if you were to jump up in the air, you might get something that looks like this. Do you see that?
Yeah.
So the person, the software developer, the person that wrote the game that you're playing, they know this. They know the quadratic formula. They know ax squared plus bx plus c equals 0. They know that based on what you do here, they know how to calculate where you're going to hit the ground.
Yeah.
And so this is not like, it's not like there's this mystery. It actually, if you go back to the game next time you're playing it and you fall, you're going to end up in the same spot every time. But if you jump, you're going to end up in the same spot every time because it's governed by the quadratic equation and the quadratic formula,
Okay. Yeah.
which is solved by the quadratic formula. There are a number of other applications, but we'll leave it at that for the time being.
Yeah. Okay.
All right, so let's just spend a few more minutes. Let's look at hopefully a fun question here. And if this is too much, and this may be, let's just look at the first line and see if I can get you to give me the answer to the first line of this. So the first line says, this is a new problem altogether. Let me just give you the first line. It says the number of footballs plus the number of footballs minus the number of footballs equals 2. Can you tell me the number of footballs?
Number of footballs.
Can you tell me like what number goes here? And it has to be the same number. Okay, so for example, let's just say it was 10. 10 plus 10 minus 10, does that equal 2?
One plus 5 minus 3.
They have to be the same number though. So
Oh.
like let's say it was 4 plus 4 minus 4. Does that equal 2?
No. 4 minus 2.
It has to be the same number.
2 plus 2
There you go. 2
equals
plus
4.
2.
4 minus 2.
2 plus 2 equals 2. So there you go. So the number of footballs is 2. Okay, so let's look at this. Let's look at the next line here. So the next line, and this is based on the previous line. Okay, so it says take the value you got from the previous line. So this is 2.
Yeah.
Okay, so you have to figure out, guess a number that when you multiply by 2 and add 2, you get 24.
Yeah.
What number would that be?
What number would that be?
Yes.
The number that would be the number that it would be. Yeah.
What
The number that the 2 plus 2, 12 times 2, 24. Oh wait, no. 11 times 2 equals 22 plus 2, 24.
So the value of the soccer ball is 11. Do you agree with that?
Yeah.
All right. So now this one's gonna be a little bit harder, but you can absolutely do this. Okay, you have to take the value of that soccer ball, which is 11, multiply it by some number here, and then add 11 to it to get 143. So you're literally guessing and checking.
Yeah. Yeah. Okay. So 11 times 11 plus 11 equals 143.
So you think this is the correct answer? You think that this is 11?
Maybe I'll make it 12. 12.
Yeah, because 11 times 11 is 121, and 11 times 12 is 132. Okay,
Yeah, 11 times 12.
so that's 12. I agree. And then the final line here is to take your previous values and combine them. So let me snip that in and see if you can come up with it. Okay, so the value of the soccer ball was what? 11. The
Yeah.
football was 2, and then the basketball is 12.
Okay. So 11 was 2. 25.
25, perfect. All right, let's try one more.
And then we'll be done.
That's up to you and your dad. Depends on
Yeah.
how much time you want us to do today.
Yeah, I think after the one more problem, then we'll be done.
Okay. So take a look at this and see if you can tell me the value that is represented by the number by the ice cream.
Six plus 6 minus 1.
They've got to be the same number. So like 6 plus 6 minus 6, does that equal 11?
No.
Okay. Let's try something else, but they're the same number. That's the idea here.
Eleven plus 11 minus 20 minus 11.
Yes. So notice the first number is 11.
Yeah.
Great. So let's try line 2. Let me snip that in.
Okay.
All right. So the line 2 here, this is 11. So what number do you add to 11 and then add it again to get 37?
$13.
13 plus 11 plus 13. And that does work. Fantastic. So then the next line, slightly more difficult.
Yeah.
Slightly more difficult here. So again, the number here, this is 13 minus some number times 13. Okay. But keep in mind, this is what you do first. You do this first. So like, let's say you pick 2, okay, which is wrong, but you do 2 times 13 first. Then
Yeah.
you take 13 minus it.
Yeah.
So 2 is not correct. But what do you say? Take 60 seconds and see if you can figure it out on your own here.
Okay. 13 minus 12.
Okay, so 12 times 13. Okay, that's a pretty large number. So 12
Oh,
times
wait,
12.
no, I don't think that one. I don't think that one.
Well, I actually think you're right here. So because 12 times 12 or 12 times 10 is 120. 12 times 3 is 36. So this is 156.
Yeah.
And then you do 13 minus that, and you get minus 143. Okay.
Okay.
So
We can be done for today.
nope, we're not quite done. So we're gonna do the next part of this.
Okay. Until what time do we have to be done?
So the next part here is using the values from the previous lines. So this is 11. Okay. You came up with 12 for this, and then 13 for this. So it's 11 minus 13 minus 12. And we can be done as soon as you give me the correct answer here.
Okay, 11 minus 13. Two, and then minus 12. 2 minus 12. It is negative 10.
That is not correct.
10.
This, we're not guessing. What is 11 minus 13? Sometimes good to just come off to the side and write that out and say, okay, what is that?
Negative 2.
It is negative 2.
And then minus 12. It is 10.
It is not 10.
14.
It is not 14.
Is it like a negative?
Well, it's something. I mean, they're both negative, so the answer is probably negative.
It's a negative 14.
Yes.
Okay.
All right. You can let your dad know we're all done for tonight.
All right, Dad. Thank you, Matthew.
You're welcome.
Here you go, Dad. Here you go.
Hello, hi.
Hi, Dr. Kiathari. So today we worked on going through the quadratic formula.
Thank you, Matthew.
You're welcome. We went through the quadratic formula and did a few examples, and then we switched to these kind of image problems as well to get some just variation on what we were doing. I also talked about some applications of quadratics, and that was all we had time to cover today.
Okay, so he was able to do it properly.
He can't do quadratic formula on his own yet. We worked through 3 examples, and he seemed very disinterested, but he did work through them, but
Okay.
I don't know that he could do any on his own at this point.
Okay.
He would have to practice. So
Okay.
if he's got time, I would love to see him, go back through the 3 problems we did, or 4. We did starting up here at the top.
Okay.
But the way we went through them was very simplistic, very, procedural, like do this, do this, do this. It's the same for all the problems. And he can definitely work through them later on if he's got time.
Okay. All right. I think, we can keep working on these problems. So I'll tell him to review. I doubt he's going to do that, but I will always remind him to go through the tutorial,
Yes,
You
absolutely.
already sent an email. So yeah, at least he was able to sit for 40 minutes. That's good.
He wanted to be over a little bit earlier, but I pushed him through and he did fine. So he can do the whole time if we need, but
yeah, no, that's fine. I think, this is good, so yeah.
Sounds good. So I'll see you guys on Thursday, and I'll send you the notes here shortly. Have a great night.
Yeah, you too. Thank you. Bye.
See you. Bye now.